Hello, this video shows how to generate code from TTool and how to use this code efficiently. Okay, so here I've opened the pressure controller, which is available on the TTool repository of models. And this model contains 4 blocks, 2 blocks representing the system, main controller and alarm manager, and pressure sensor and alarm actuator represent the environment. In pressure sensor, let's have a look at this system. In main controller waits for a pressure value. If that pressure is less than a given threshold, then the system goes back to first high pressure. Otherwise, it goes to wait for second high pressure. Then, when the system gets a pressure value, a second one, and the second value is higher than this threshold or equal, a high pressure message is sent to the alarm manager. The alarm manager, when it gets a high pressure, it sets a timer, it sets the alarm to on. If it gets another high pressure, it resets the timer and sets it for another duration. Otherwise, when the alarm timer expires, alarm off is sent to the alarm actuator. Let's have a look at the sensors. First, the pressure sensor, it waits for 1 clock cycle, so every 1 milliseconds or seconds. It first it executes is in code. If is in code is equal to true, that is we have generated the code, then we execute pressure is equal to reading pressure. We really execute a C function that is expected to return the value of a pressure. Otherwise, if we are just simulating the system, we compute a random value. And then we send this value to the pressure controller. The alarm actuator has 2 possible signals from its main state: alarm on, in that case it executes a method set alarm, or to true, or alarm off, then it executes set alarm with a false attribute. These methods, when simulating the system, are not executed. Same when doing some formal verification. These methods are meant to be executed only in the generated code from the model. So when you generate the code of a model, you generate a code representing your model, but also all the code that the user can add to this method. Okay, the idea is such a model of an embedded system is to model the environment we've seen before, the sensor and the actuator. So when you're going to generate code, we don't really want to execute the code of pressure sensor and alarm actuator. So one way to do is to use real sensors and an alarm actuator and to use them from the C code. Or another way to do is to program a simple graphical user interface that will interact with this model. So if we want to interact with the graphical user interface, we first need to program it. So actually we have programmed a graphical user interface. So here in TTool executable code example, we can first compile the different Java classes which are provided. And then we can execute a graphical user interface, which is here, so in which we can play the role of the sensor and see the alarm is on or off. Yet we still need to connect the code, the C code we are going to generate from the model, to this graphical interface. So let's put this aside and we'll come back to this graphical interface later. So in the model, I would like to say that in the pressure sensor, for reading the pressure, I would like to read the pressure sent by the graphical user interface. And when there is in the alarm actuator, set alarm. I would like to write alarm on or alarm off on the graphical user interface. To do this, I'm going to customize the code of these functions. So if we go back to the block diagram, we see that in the block there is an area called block code. If we double click on this, we are in a prototyping tab. Okay, and there are two different views. This one is to provide an implementation to the functions, to the methods provided by the user. So for example, for reading pressure, we are simply returning the value of a global variable. Okay? If we go to alarm, then to implement set alarm, which takes as attribute a boolean, that first, if there is a bool, we are doing a printf, and we're sending a datagram. We are communicating with the graphical interface using datagrams. We send the plus value. If alarm is set to off, then we send a minus value. And the graphical user interface will listen to datagram packets. Okay, and this send datagram method is defined in the global code of the application, which is the other view. In this global code we put, we can define several methods, and an important one is the first method that will be called even before the code of the model is executed. So in this user init, we simply create a socket here, and we get a socket descriptor, and then we just try to debug something to the graphical interface to see if it has correctly received our message. And then we start a thread that is able to wait for datagram packets. The receive datagram method is executed by this thread. In receive datagram, basically we have a buffer in which we're going to put the receive datagram packets. And then there are several cases. It could be either an error, okay, or we receive something which is larger than the buffer, or we receive a datagram packet. And if that datagram contains a pressure equal to something, then it means that we got a new pressure value, which has been sent by the graphical user interface. In that case, we execute pressure datagram. Pressure datagram simply gets the int value which is stored in the buffer and sets the pressure variable, which means that each time there will be a reading pressure, you remember that this is this variable pressure that will be read by pressure sensor. So by sending a datagram, we are able to modify the value of this pressure variable. Similarly, in alarm, we've seen that there is a send datagram. This send datagram method is implemented there. First we do a printf to debug, and then we do a send2 on the socket we have previously configured. And we send minus for alarm off and plus for alarm on. Okay, so now we can generate the code of this system. It's with a gear, generate code, compile the code, then we still have our graphical user interface, and we're going to execute the code. Okay, so the system is running. Now I would like to know what's happening in the system. We know that the alarm is off. Okay, if I send new value, now the alarm is on because it's over 20. Now I'm going to decrease the pressure value, and after some time, now the alarm has been set to off. Okay, so I would like also to be able to monitor what's happening in the generated code, so I can click on results, show trace from file, and I get a sequence diagram which shows exactly what are the different actions that have been executed in my system with a sequence diagram. Now if I send again the alarm, I update the transaction, and we're going to see that the pressure was 21, high pressure, and the timer was set. Okay, if now I set the alarm, the pressure to a lower value, the alarm was set to off here. We see it here, and we see that the value is lower. Maybe I can refresh to see, yes, the timer expired and the alarm was set to off. So of course, there are more complex examples provided with TTool, including the microwave oven. There is also a documentation on code generation, which is provided on the website of TTool in the avatar section. Thank you and enjoy TTool.